Hi, everybody. Today I'm going to go over some Z-test examples, and we'll go over t-test examples on the next day, and then some one-prop Z-test examples. Then next week we'll put it all together, and we'll look at the estimations, in other words, the confidence intervals, along with the hypothesis tests. So let's take a look at some examples I sent out to you a little bit ago, and some examples that I worked out in these examples. These are all worked out, including the calculator input and output. So our first example, example A, retail purchaser from Macy's wants to test the claim that the mean shoe size for US females is 7.5. She knows the population standard deviation is 1.6. To test this claim, she randomly selects 250 customers and finds the mean of the sample is 7.62. At a level of significance of 0.10, is there enough evidence to support the claim that the mean US female shoe size is 7.5? So is means equal, and that's the claim. So mean, we use the population mean symbol, which is this mu symbol, and it equals 7.5. That's what the is. Now I asterisked it because that's the claim. And when I write up my final answer, I'm going to have to either support or not support the claim. I may reject or fail to reject A0. A0 is not necessarily the claim, but I will have to support or not support the claim. Okay, then HA is exactly the opposite of A0. So that says mu does not equal 7.5. Now in my 6 steps that I typically use, I list the level of significance so we remember it in part 2. In part 3 and 4, we calculate the test statistic. We're going to use a Z-test because we know the population standard deviation. That's the thing that makes you use a Z-test versus another test. And the formula is X bar over the hypothesized mean, which is a 7.5, over the standard error, which is that population mean divided by the square root of n that we saw back in the chapter that dealt with the central limit theorem. And then we also calculate the p-value in step 4. Now these two values rather, were calculated with the TI. So I'm going to scroll down and look at the screenshots that I have with the TI. Okay, so here's our first set of screenshots. Here's the input. Okay, so we go stat, arrow over to tests, and select number 1. That's a Z-test. We select stats. The only time we do data is if we have a list of data and we put it in list 1 and we use then that particular data to calculate all this. But we have the mean given to us, we have the standard deviation given to us, we have a sample size given to us, so we don't have to worry about that. Okay, so mu0 is always what's in the null hypothesis, that's 7.5. Sigma is the population standard deviation, 1.6. X bar is the sample mean, that's the mean from the sample, so that's 7.62. The sample size is 250. This part is pretty self-explanatory. This line right here, where it says mu and then colon, that sometimes confuses people. We highlight the symbol that's in the alternative hypothesis. So we have a not equal to an alternative hypothesis. So we highlight and click enter. And then we go down to calculate and press enter. And we get the following output. The output says we have a mean equals 7.5. We know that already. The z-score is 1.19. I'll round that 2 decimal places. And the p-value, this p represents the p-value. And so that would be 0.2357. And I'm going to take that to 4 decimal places typically. It gives me X bar, which we already put in, and the sample mean. These two scores right here, the z-score and this p-value, those are the 2 scores that I really want to keep my eye on, because those help me then decide what's going on. So let's scroll back up. Let's take a look at what we have. So we have that. And then we have, I rounded that 2 decimal places, the 1.19. And then we have this, 0.2357. That's our p-value. Then we go to that decision rule that we have from that PowerPoint that I sent out a few days ago. When the p-value is larger than the level of significance, we fail to reject A0. So what does that mean when we fail to reject A0? That means we're not tossing it out. We're going to keep it. That doesn't mean it's true. Just the data suggests that it's the valid option. Okay, so when we fail to reject A0, we've got to go back and look at what the claim was. If the claim is H0, we're going to support that claim. If the claim was HA, we're not going to support that claim. because we failed to reject A0. So since the claim is shoe size is 7.5 and that is A0, and we failed to reject A0, we can support the claim that the female mean shoe size for females in the US is 7.5. In other words, that's supported. Let's look at another example. This is example B. So in example B, whoops, that's a little too far. Let's go back up. Example B, a car manufacturer claims that the fleet gas mileage is more than 28.5 miles per gallon. To test this claim, you randomly select 38 cars and find that the mean is 29.5 miles per gallon. You know that the population standard deviation is 1.1 miles per gallon. So this verbiage right here, population standard deviation, we're going to use the Z-test. If it just said standard deviation, we'd have to do something else. That would be a t-test. We'll take a look at that next time. Okay, can we support this claim that the gas mileage for the fleet is 28.5 miles per gallon when a test level is 0.05? So let's first analyze what we have. So first off, the claim is at the mean, and I should have a mean symbol there. Let me put one there so I remember. That the mean is greater than 28.5 miles per gallon. This is the claim. So HA this time is the claim. So if we reject A0, we're going to support that claim. If we fail to reject A0, we cannot support that claim. A0 is exactly the opposite of greater than, and that had to be less than or equal to 28. The mean is less than or equal to 28.5. We report our level of significance, 0.05 or 0.05. Our test statistic calculated the same way because it's a Z-test, and it's the mean the sample mean subtracted from the hypothesized mean, the one in the null hypothesis, divided by the standard error. And I get 5.6 when I put that into the calculator, that information. And we get this, we get a p-value of 1.05 e minus 8. So what that e minus 8 means is that we move the decimal 8 places to the left. That gives us a really tiny score. That gives us a decimal point and then 7 zeros and a 1. So if we're rounding 4 decimal places, that rounds to 0. So our p-value for all intents and purposes is 0. So 0 is definitely less than 0.05. When the p-value is less than that level of significance, we reject A0. Since the claim, since we rejected rather A0, and A0 is not the claim, we can support the claim, which is the other one, HA, that the mean fleet mileage is greater than 28 or 29.5. Should actually be 28.5. Let's go down and look at the input and output for that. So the input for B, again, I go stat, tests, choose number 1, and I'm using stats again because my mean and standard deviation are all given to me. The hypothesized mean is 28.5. The standard deviation of the population is 1.1. And the sample mean is 29.5. Our sample size is 38. So again, this is all pretty self-explanatory. That's from the problem. This part is from HA. What's the symbol in HA? The symbol in HA was greater than. So we highlight greater than and press enter. Then we go down to calculate, and we get this output. 5.60 and 1.05 e minus 8. X bar is a 29.5, n is 38. But again, the z-score and the p-value are the two important values that we want to hang on to. So we put those in step 3 and 4. That helps us decide in step 5. And then we put it all together in step 6. Hopefully this helped. Have a good day.